So in this video we're going to calculate an arc length with respect to the y-axis. In the previous video we did it with respect to the x. And what we want to recognize is the reason for wanting to be able to do it both ways is sometimes it is the case that integrating with respect to the x-axis will yield an integral that you can't do into a closed form. And if you just convert things into a y-axis world, you can integrate it, and vice versa. So when you're working through homework, if you can't do it one way, then you try it the other. This one, though, is more straightforward than that. It says find the arc length for the graph x equals 1/3 y squared plus 2 to the 3/2 on the interval, closed interval, from 0 to 4, so letting y run over that interval. And this is already solved for x, so clearly this is an x equals f of y type of a beast. And if we're integrating with respect to the y-axis, then the arc length formula, which we developed in video 1, is going to look like this. It's going to be the integral running from 0 to 4 on the y-axis of the square root of 1 plus the f prime of y squared, or x prime squared, depending on the notation you're using. And this is going to be a dy. So once again, we need to take the derivative, we need to square the derivative, we need to add 1 to the derivative. So that's a bunch of work that's probably better done as scratch work. So if we take the original equation, which is x equal to 1/3 of y squared plus 2, all to the 3/2, we can then take the derivative, because we need to do that. So this is my scratch work column, so x prime equals, and when we take the derivative, this 3/2 is going to come down, so 3/2 times 1/3 is going to give us 1/2. We'll have the y squared plus 2. We need to reduce this exponent by 1, so it'll be to the 1/2 power, times, we need to multiply by the derivative of the inside, so we're using the chain rule, so the derivative of the inside is just 2 times y. And this simplifies a little bit. 1/2 of 2 is 1, so we'll just get 1y times y squared plus 2 to the 1/2. So here's our x prime. But we know we're going to need to square x prime. So let's go ahead and do that. And if we square x prime, we get y squared. And we get the 1/2 power squared is going to cancel. This is a square root, and the squaring will cancel it, so we'll be left with the y squared plus 2 sitting here. And then we also see that we need to add 1 to x prime squared. So we're going to have to go 1 plus x prime squared. So this is going to equal a plus 1 over here, so we'll add 1 to both sides. And if we do that, we can expand this out a little bit. We get y squared times y squared is y to the 4th. Y squared times 2 is plus 2y squared plus 1. And so this is the mess right here that's going to need to go underneath the radical sign. So it'd be nice if we could write it in a form that's squared, so we can take the square root of a square. So we're going to try a y squared here, because y squared times y squared is y to the 4th, so y squared squared is y to the 4th, and they're all pluses, so we're going to go plus 1, because 1 squared is 1. And then we want to make sure we get the middle term, which we will, because we're going to get y squared times 1 2 times, which will give us 2y squared. So this can be rewritten as a binomial squared. So now I'm ready to plug this in underneath the radical sign. I've done my scratch work. So we pop over here. This is the integral from 0 to 4 of the square root of y squared plus 1 quantity squared dy, which is equal to the integral from 0 to 4, the square root of the squaring, equals y squared plus 1, but only if y squared plus 1 is non-negative. But because we're squaring the y squared plus 1 is never negative, so we can just cancel the squaring with the square root, and this is a dy, and now we can integrate. So we integrate this, we get 1/3 y cubed plus y in parentheses from 0 to 4, and now we can move our 4 in. So we get 4 cubed, bringing the form, we get 4 cubed over 3 plus 4, and it's minus parentheses plug the 0 in, but when we plug 0 in for y cubed and y, we're just going to get 0, so there's really no need to plug the 0 in. And so this equals 4 cubed is 64 over 3 plus 4 is the same as 12 over 3, so there's with our common denominator, and we wind up getting 64 plus 12 is 76 all over 3, so that's the arc length.